1.5, describe angle pair relationships. So I'm going to read through. Two angles are complementary angles if the sum of their measure is 90 degrees. So C is smaller than the next angle in the alphabet, because the next angle is, two angles are supplementary angles if the sum of their measure is 180. So the way that I remember is C is less than S in the alphabet, so C goes with 90 and S goes with 180. You have different ways to remember, it's just a little tip. Each angle is the supplement of the other. So complementary angles and supplementary angles can be adjacent angles or non-adjacent angles. Adjacent angles are two angles that share a common vertex and side but have no common interior points. So let's look. These are both complementary angles, meaning they add up to 90. This is adjacent angle. They share the same vertex, but they're different angles. So that means these, apart from adding up to 90, are what we call adjacent. These are also complementary angles. That means they both add up to 90, but they're non-adjacent. Okay, so they have different, this could be 50, this could be 40. However, it adds up to 90. Again, supplementary angles, these are adjacent. You can see they share the same vertex here. And then this is an example of non-adjacent angles that add up to 180. So we're going to start with the first example. Okay. In the figure, name a pair of complementary angles, a pair of supplementary angles, and a pair of adjacent angles. Okay, so you don't have to start in order, but when you do your work, you definitely want to have it in order. So the easiest thing is the adjacent angles. So the adjacent angles would be these angles, okay? So adjacent angle would be CAB and DAC, because they're right next to each other. So that is an example of adjacent, a pair of adjacent angles. Now the first one is complementary angles. So we know that complementary angles add up to 90. So that obviously it's not going to be these two. So if I add 58 and 22, I get 90. So C, angle CAB plus angle RST would be an example of complementary angles because they add up. 58 plus 32 would give us 90. Now a pair of supplementary angles, that means they add up to 180. So 122 and 58 do add up to 180. So a pair of supplementary angles would be angle DAC, or you can call it angle CAD, it doesn't matter. So that angle plus this angle, RST or TSR, well, RST, you want to do it in alphabet, yeah. So RST and CAD. Okay, so let's look the way they did this. So here, like I said, we had our adjacent angles, then at the top one is the complementary angles, and here are the supplementary angles. So you can use a calculator, so make sure you always have your calculator because you're going to be adding things even in equations. So you always want to have that on. Okay, example 2. So given that angle 1 is a complement of angle 2, and angle 1 is 68 degrees, find angle 2. Now you have to remember the complement means that they add up to 90. So all you have to do is subtract 68 from 90. So 90 minus 68 degrees, you can put that or do it afterwards, equals 22. So that means angle 2 is 22 degrees. Okay, you do not have to put the line through. I just do it, a habit, I think, from growing up in England. They kind of did that. So angle 2 is 22 degrees. So here, given that angle 3 is a supplement of angle 4, and you can see that these are adjacent angles, just like this was adjacent. They add up to 180. So if this is 56, they want you to find angle 3. So that should be fairly easy. So 180 minus 56 degrees. When you do that, you get 124 degrees. So angle 3 is going to be 124 degrees. So that's pretty straightforward. Let's look at a word problem example. I just want to look at this and we'll work it out ourselves together. So let me go in a little bit so we can see everything without seeing the work. Here we go. All right. Find angle measures. So they might give you a word problem, but you're using the same concept that you are even when you don't have a word problem. When viewed from the side, the frame of a ball return net forms a pair of supplementary angles, okay? So here is your supplementary angles. This angle and then this angle, okay? So this and this give you the two angles that are adjacent to each other that are supplementary with the ground. So find angle BCE. So BCE is the bigger angle. You can see obviously that's greater than 90. So you should be expecting an obtuse angle for that one. And then angle ECD. ECD is less than 90, so that's an acute angle. So you would use an equation. So we know that it adds up to 180. So let me go ahead and move this up so we have enough, so I can put this on here, okay, and show the work. So here we go. So I'm going to say the angle B, C, and D is equal to angle BCE, okay, this big angle, plus the angle ECD. And I'm just doing this so I can fit it on. I didn't do the M in front, but it means the same thing. So we know the total straight angle is 180, so replace that. Then we know the bigger angle, the obtuse angle, is 4x plus 8, plus the smaller angle is just x plus 2. And they want us to find both angles. So we set up an equation like we did before, and we're just going to go ahead and solve. So 180 degrees equals 4x plus x, that's 5x, plus 10. 8 plus 2 is 10. Subtract 10. 170 equals 5x. Divide by 5. And x is 15 is 34. So I know that x is 34. But I have to go back and plug it in. So I know the bigger angle is 4x plus 8. So 4 times 34 plus 8. And the smaller one is 34 plus 2. Sorry, you can see. It's trying to squeeze it all on here. So I know that this is 36. And this is 4 times 4 is 16, 12. 136 plus 8 is going to be 144. So one of the angles is 144, the bigger angle, and the smaller angle is 36. And that makes sense because one of them was clearly well above 90 degrees obtuse angle, one is an acute. And the way that you double check that it's right is add them together, make sure that you get 180. So 10, 8, They add up to 180, so that lets me know it's correct. So there, you're using algebra a lot like this to go ahead and plug in, find x, then solve it, and then go back and plug in and answer the question. So you wouldn't just leave it as 144 and 36. Look how they write it in the book. You would either write a statement, the angle measures are 144 degrees and 36, or you would say angle BCE is 144 and angle ECD is 36. All right? So make sure you always go back and plug it in and answer the question. Okay, so we've looked at supplementary, complementary angles. Now we're going to look, and we've looked at adjacent, non-adjacent. So we're going to look at angle pairs. So all of this vocab is going to come back in the geometry book. So you have to be straight with it. You have to remember what everything means. It's not difficult, it's just you've got to understand when they say linear pair, adjacent, non-adjacent, what does everything mean? Array, a line, so forth. So two adjacent angles are a linear pair. So you can see here angle 1 and angle 2 are linear pair. If their non-common sides are opposite rays, so this and this would be opposite rays. The angles in a linear pair are supplementary angles. This is really important, so make sure you write that down. You always take these examples and write the notes. So anytime they tell you it's a linear pair, or you can see it's a linear pair, you know it adds up to 180. Two angles are vertical angles if their sides form two pairs of opposite rays. So angle 3 and angle 6 are vertical angles, so let me label them. So they might show it like that. That means that they're vertical pairs. Then angle 4 and angle 5 are vertical pairs. To distinguish them different, now they might put two little half circles on there. That's how they do it in geometry. So that means these are linear pairs and these are linear pairs. Okay, so we're going to identify linear pairs here in example 4. Identify all the linear pairs and all of the vertical angles in the figure at the right. So it says to find vertical angles, look for angles formed by intersecting lines. So intersecting lines are going to be what you're looking for. So if we're looking here, angle 1 and angle 5 are vertical angles. I'm just going to do that. Those are vertical angles, and you can see that they have intersecting lines here and here. Okay? And to find linear pairs, look for adjacent angles whose non-common sides are opposite rays. So look for opposite rays. That can help you. So angle 1 and angle 4 are a linear pair. What I do is look, I put and make sure I have a ruler or a straight line. I look and see where it adds up to 180. So angle 1 and angle 4 make a straight line of 180. I can tell that's a linear pair. Okay? You can also do it here. You can see that that is 180. So angle 4 and angle 5 make a linear pair. And the reason you wouldn't worry about 1, 2, and 3, because that's 3 of them and they're not making a linear pair. So this angle, straight line here, 1 and 4 add up to 180, so that makes a linear pair. Then this straight line here, angle 4 and 5 add up to 180, and that makes a linear pair. So it's pretty easy. I always use my pencil or ruler, and I find out where everything is a straight line, and then I can see real quick where they add up to 180 and what forms a linear pair. Okay, so here's an example, and again we're going to work this out together. Two angles form a linear pair. So as soon as they tell you that they form a linear pair, in your mind you should say, okay, that adds up to 180. So the measure of one angle is 5 times the measure of the angle. Find the measure of each angle. So here they've drawn it out for you, but if they hadn't, this is exactly what I would do. So a linear pair, 5x, that's an x. One is 5 times bigger than the other. So there we go. It doesn't have to look perfect. So what they want to do is for you to tell how much each angle is. Okay. So we know that they add up to 180. So the total angles add up to 180. And then the first angle is 5 times the second angle. So the first angle plus the second angle add up to 180, and so there's your equation. So 180 equals 6x, combine like terms, divide by 6, and x is going to be 30. But that doesn't answer the question, so be careful in geometry that you go back and you answer the question. So the smaller angle is 30. I'll put that. Always want to write, if they don't label, is 30. They don't have any ABC, so it's just that. Then the larger angle, and you always want to write this or go back and do this, is going to be 30 times 5, because it's 5 times bigger, and you should be able to know that that's 150. And then if you add 150 and 30, you get a total of 180. So now you found the smaller angle and the larger angle. So are you beginning to see how algebra plays a huge part in geometry? It does. So you have to be strong in algebra skills, especially in solving these equations and setting up equations. Alright, so let's see. Let's do a recap. So it comes down to this. Alright, concept summary. So it's good to look at this, and let's go through real quick. There are some things you can conclude from a diagram and some you cannot. For example, here are some things you can conclude from the diagram at the right here. All points shown are coplanar. You can conclude that. Points A, B, and C are collinear. See, it's all on the straight line here, so you can assume that. AC, which is here, BD and BE intersect at point B. You can see that they all intersect here. These 3 segments and lines intersect, or rays, 2 rays and a line intersect at point B. Angle DBE, so angle DBE and angle EBC are adjacent angles. You can see that this angle and this angle right next to each other, so they're adjacent, and the line or the angle ABC is a straight angle. Point E, so point E lies on the interior of angle DBC. So this point lies on the interior, on the inside. So that's everything that you can conclude from that. Nothing more is labeled. So they're going to tell you some of the mistakes that people will make. In the diagram above, you cannot conclude that AB is equal to AC, because it does not say that it bisects. So you can't say this segment is the same as that. That would be false. There's nothing in there that indicates, there's no marking showing they're the same. So that's one thing that you cannot conclude. That angle DBE is congruent to angle EBC. Doesn't show that, so you cannot assume that they're equal to each other. Another thing that people will assume, because it looks like that, and I've mentioned it before, they would assume that this angle right here is a right angle. But again, you cannot say that. There's no square. They did not mention that. So you cannot assume that it's a right angle. So be careful when you have a diagram. You don't assume things that are not there. For these segments to be equal, they would have marked them. If this was a right angle, it would be marked with a square. If these angles were the same, they would have the same markings like here. So be careful about that. You can only go by what information is given to you. Okay, we'll be moving on to the next section, so make sure you take your notes, show all your work,